So I was on TikTok talking about something. Now I'm gonna finish it here because I need more time. But basically, what I was saying is there's um, analogies, but if you use analogies to represent um, equivalences, you could take like A is to B and C is to D. And in math, it would be ratios. But if you do it with math, the analogies would be not in terms of numbers. So you could take blue sky is to that blue water color. So color, it could be a different unit. Then equations could have positive and negative as opposed to a number value, or equations could have a different value, like, I don't know, how many times you fapped. So if you take this guy in an argument, his positive stuff, his negative stuff, you add those. The guy arguing with, his positive, his negative, like the good and the bad of what he's saying and doing, you add it all up, you get outcome. Then you want, like, make it more fancy exponents, you could take, you raise, let's say it's no fap. Let's say variable x is no fap. How many, the unit is, because you can set the unit, it doesn't have to be a number. So you can set the unit to be days gone without no fap, which is a number, but let's say it wasn't. Let's say it was just, I don't know, something. So you set that just no fap 1 times no fap equal to something, then you take no fap raised to the power of 2, no fap squared. So that's the thing you set it to squared. So if you set no fap equal to, I don't know, blue balls, then you have blue balls squared. I don't know, but that's basic equations with abstract real life stuff. Now, and that's all math. That's not some, like, you applied math, you could do that with it. They've already done stuff like that. They just do it with advanced methods to measure. Like, they won't do it like in their head, though. They'll have like a team of people collecting data, statistics, and they'll come up with it like that. It takes more effort, but this is a shortcut. But then there's meanings. So meanings is like, if there's a true meaning, so there's logic math where they have true and false. In logic math, they don't have numbers. So you could say, okay, two people arguing, what's the truth value of this person? If you say true, it's no longer two sides in the truth. Their truth value is the truth. Their side is the truth. And then the other person would be false. So that's logic math. If you have if-then statements in logic math, you could say, okay, this, if this, then that. And then you could have chains. So you could say, if this, then that. If that, then this. And with the if-then statements, you could have sort of an ultimate if-then statement, like, if this, then always that. Like, normally in logic math, if then is always, but I'm gonna tell you it's not always. So if then may be like 75% of the time. So I'm gonna tell you do if thens, but if you have 100% guarantee, make that like a loophole. You spam that, and then but going back to where I left off of my TikTok, if you want to make your equations fancy, take variable x, then add something to it or subtract something to it, then like square it or cube it, and then you want to like graph it. So if I want to graph nofap plus 3 squared. So in math, on the 4 quadrants of the graph, underneath the graph, not all the way down to infinity, just until wherever the quadrant line is. So if it's if this is the graph and this upper northeast quadrant here is where the graph is, like let's say it's just y equals 2x, I don't know, or y equals x squared, so it would go like that. So either here or here and here, like the top 2 quadrants. So the integral, the area under the graph, the rate of change, the derivative of that is the graph. So let's say I have y equals 1x. So just a line like that. Then, like, let me get a piece of paper. Do I have a pen? I think I have a pencil in here. Look at my tiny ass pencil. Look at my tiny ass pencil. So we have our graph. So the shaded where the integral is. So here's my graph. So it's backwards because it's recording, it's not mirrored, but this is y equals x, and the part underneath, but not all the way down, just up into the line is the integral. So that area underneath the curve, under the graph, if you take the rate of change of that, then that's the graph. So that's this line. So like this is advanced stuff how to read graphs now. This gets into calculus. But let's say I plot a point. Okay, so I just plotted a point there. So everything underneath there from here and including here, I think too, would be either that or it's just whatever the area value is underneath there. So but that would be, at that point, would be the integral of that would be whatever shaded amount is underneath. And then on the other side of that paper, I have some stuff I already explained, like with the positive and negative. Like you have x sub 1, x sub 2, so x sub 1 could equal the positive of a guy's statements in an argument, and x sub 2 is the negative. So you add them and you get, because you can't say, oh, we're going to talk about his morals, his ethics, his intelligence. You'll list out endless things if you say his argument equals like hundreds of different types of categories. So I just limit it to x sub 1 positive, x sub 2 negative. Like, not signs, but I mean it is signs. Like the negative would be negative. Like, maybe let me just show you. So I had, that's too much for you to read. I'll just read it to you here. So I had, x sub 1 equals 8, x sub 2 equals negative 2, so that's 6, positive 6, and then y sub 1 is 4, y sub 2 is negative 6, so y is negative 2, so y minus 2, minus 2, so it's 4. So if it's on a scale of 1 to 10, it gets to 4. It can go into the negative, so the outcome of that argument is average. And you had a guy who's an 8 and a guy who's a 4. So automatically, because the positive x sub 1 is 8, the negative would have to be negative 2, because it's on a scale of 1 to 10. So that's one method. Another method besides positive and negative is to use numbers, but of other units. Like how I talked about the NoFap, number of days that you resisted. And I could say blue balls once per every 4 days NoFap. So, and then NoFap plus 3. So you went 4 days, you add another 3 days, then you if you square it, that means, what does that mean? That would mean 4 plus 3, so 49 days. So 49 days, how many blue balls is that? I don't know, 12. And then, if you wanted to do rate of change, so let's bring back the graph. So let's say I have, what do I want to do? Let's say I have, memory. So let's say that my memory is x and y equals let's say memory is x, oh man, I missed the stream. So memory would be measured, what would the unit be? I guess actually the unit could be many different things. What do you guys I have no viewers in Instagram Live, but well, let me pick a different thing that's easier. Let me go back to NoFap. So you have Jay's NoFap, and then oh, he went live again. Oh, he must have just went live, ended, and then went back. When I'm taking you to the toilet with me, I want to take a piss. I won't show it though, but I need a piss. I'll leave you out here. You didn't hear nothing. You didn't hear nothing. So wait, did I show myself peeing? I hope I didn't. So back to the NoFap math. So let's say NoFap the rate of change of Jay's NoFap. Wait, rate of change is with respect to something. So rate of change of blue balls with respect to NoFap. So I said 1 blue ball is every 4 days NoFap. So it would be 1/4. But let me get back my pencil, my tiny pencil. So let me go back on the graph. So I'm gonna make a new graph. Oh, I poked a hole through my paper. So let's say it goes like that. So here's what I have. That's the graph of, so Y up is blue balls, and X, NoFap is X. So let's see. So let's draw the axis. So here, 1, 2, 3, 4. So at 4 and Y, so there's 8. So at about 2, there is 8 blue balls. So linear is too easy. Real life stuff is curve, lines, graph. So I'm gonna say that, so once you can graph it, if you can graph it, you already have the equation. So let's try to graph something during this IG reel that will give us a loophole. Let's try to graph memory, or I don't know, discipline. Let's try to graph memory. So let's draw a new graph. Big graph this time. So we're gonna have some so here's what I got so far. So with memory, I think the unit is gonna be I think it's gonna be I think it's gonna be time. Like, because it can't be how many things you can remember. It has to be, and it can't be positive, negative. It can't work like that on this. And positive could be like, on a scale 1 to 10 doesn't make sense. So I'm gonna say how long back you can remember, and how much. How far back, and how much of that time you can remember. So gonna be multiple variables. So let's say y equals x equals, so x is gonna be memory, so equals, you do a bracket, you have to do a bracket like that, the bracket. So x sub 1, then we're gonna get the memory loophole. X sub 2, so x sub 1 is gonna equal how far back, and x sub 2 is gonna equal x sub 2 is gonna equal how long how much event, how far back and how much of an event. I think that's good. Wait. So y is gonna be y is gonna be for that for this. So automatically x is gonna be like 10 minus y is gonna be like something minus x minus something, I don't know. And then what other variables do we need? So let's say how far back, so let's say 10 years back. 10 years x equals, then let's say x sub 2 is and let's say x equals x equals what is x equal? So let's say 10 years and let's say 10 minutes. 10 years and 10 minutes. So then let's say x equals so this is getting complicated because to get x, now to get memory, x equals memory. I need another equation to match x1 and x2. So so 10 years, 10 minutes. So let's say that then you have let's say you have what other variable would I need? I have to lower this resolution. So if I have how far back, how much of an event, so let's say x sub 1 equals 5 years. So let's say x sub 1 times x sub 2 times no, let's change the variables. They're not x. Oh no, let's keep them x. Times x sub 3. right? Oh, I think I know. Wait. So let's pause. So if 10 years back I can remember 10 minutes. So that's 10 years, 10 minutes. So let's say 2 years back I can remember 15 minutes. So now we have an equation. So, so I think this is getting into systems of equations. So, and we have forgetfulness. And what else do we have? So what is forgetfulness? Well, forgetfulness would also be, so here's forgetfulness. Forgetfulness is, where do I write it? Here. Y sub 1 equals how far back. Y sub 2 equals how much of event. So, how much of event forgotten? How much of event remembered? So, so let's say that now I'm gonna have another variable. So z equals total 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 event. C equals total no. C equals everything that happened in the event or thought. So, alright, we're getting closer. Oh, someone joined. So let's say, so now we're getting closer. So let's say 10 years ago you remember 10 minutes. So let's say it was 25 minutes. Pick a hard number. So now we can do the equation. So we have z equals 25, and that's a 2 years ago 15 minutes. So let's say it was 18 minutes. So z equals 18 minutes. I don't know. And then let's say so Um, how do I do this? Wait. Oh, maybe, uh, maybe multiply or divide. So, if I multiply, it would be, too long. I think I divide, right? Because if I have, how would I graph it? Wait, let's try to graph it. Because I'm getting stuck. Graphing it is easier. So, let's say, so x, so we have, but x is one variable. Let's just, how do I have to solve this then. Okay, so, so what does y equal? Okay, y, how far back? So where would I write this? So, I'll write it up here. I'm running out of space on my paper. 10 year, 10 minutes, 15 minutes, 2 year, 15 minutes, 2 year, 3 minutes. So let's see. So y has y sub 1, y sub 2. So 10 years, so, I'm trying to get the memory to be one value, because it's supposed to be like an equation. Maybe if I do like a system of equations, so like, I need the derivative. I need 3 points. I need 3 points. Okay. So then let's add a third point, because you need at least 3 to make a curve. You need 2 points, 2 points to make a straight line, 3 to make a curve. If I had my graphing calculator, I could do it. So I'm going to say 6 years ago, I remembered 11 minutes. And this is all assuming this is like the best you can do. Because with memory, you could always, like, it's experimental. This isn't like definite. Like if a year ago you remember nothing and 10 years ago there's something you remember crystal clear, that doesn't mean your memory short term sucks. It could have just been something you didn't pay attention to. So this doesn't really work like that. But 6 years ago, 11 minutes, and let's say z equals so the memory then could be like wiggly line. Meaning to memorize better, you want more focus. So as you go further back, you remember less. You go closer to the present, you remember more. But I'm gonna set z equal to 20 just for the purpose of this. 20 minutes. So now we have 60 years. 60 years. 11 and 20, yeah. 11 minutes. 9 minutes. So now I can plot my graph. So these are all positive numbers. Where is the negative? I guess I'll plot forgetfulness too. So I think how I want to do the x with the x sub 1 and x sub 2 is I'll multiply or divide. Because I have 10 years, 10 minutes. So 10 years ago, you remember 10 minutes. So if I graph that as 100, and then what else would it be? The 15 that I forgot? Maybe, you know what? I need multiple variables. I need, so let's try this. I'm gonna plot it like this. I'm gonna say 5, 10, 15, 20, 25, 30. So here's 5. Then on the y-axis, let's say I have y, so that's forgetfulness. Oh, let's just say Oh yeah, let's multiply it. Okay, I need a new piece of paper. Let's just continue it in this journal. Or I'll rip out a sheet. Here, I'll rip out a sheet. There. I ripped out a sheet. Got a sheet of paper. So, let's say, wait. What am I plotting? So, alright, I'm gonna draw the graph. Okay, nice and easy. So, what am I going up to? 100? Okay, so, let's say 20, 40, 60, 80, 100. And what's y going up to? Should have left more space. Yeah, definitely should have left more space. What's y going up to? Y, how far back, how much forgotten? Oh man. Well, that's already 150. That's 54. That's... Wait. Oh. Wait. Oh, that one's only 6. So 150. So let's just say 20, 40, 60, 80, 100, 120, 140, 160. So now let's do it. Oh, I got a few. They left. So let's do so 10 years back times 10, so 100 here, right here, and then what's the y value for that? So 100 is here, and 150, so right about here. There. Then 30 and 6. 30 and 6. So about here. and then 66 and 54. So 66, okay, and 54. So somewhere about here. So if I try to graph these, then now the curve looks something like this. So I graphed it. So that's the memory of this fictional thing. That's not me. Okay. So I kind of missed the points connecting the dots, but so with memory, then I guess so you need focus. Man, I didn't really accomplish much in this IG video. I feel like I wasted you guys' time. But oh well. More math later. More math to come.